let's try to solve another Leetcode problem. 1362 closest divisors. So we are giving an integer num, and we're gonna have two different integers. So find the closest two integers in absolute difference whose product equals to num plus 1 or num plus 2. So let's just try to use example. So if we have a number 8, now we're gonna have another two numbers. So it's gonna be 8 plus 1, it's gonna be 9, and num plus 2, it's gonna be 10. Now we want to find the closest two integers in absolute difference whose product. So it means if this is a 9, so basically we're gonna find a number with 3 times 3, and another number for this 10. Basically we can find 2 times 5. So the absolute difference for this 2 and 5 is going to be 3, and absolute difference of 3 and 3 is going to be 0. So we're going to return this 3 and 3. Yeah. So for this problem, basically we're going to use how to find the divisors of a number. So for example, for this number 8, now we turn to 9, and for this number 9, we're going to find all the divisors. So it has 1, 3, 3, and 9. So the closest, of course, should be 3 and 3. But we can compare together with a tuple or with a pair. If we find number 1, so we can find number 9. But the distance is going to be 8 because 9 minus 1 it is 8. And next we're going to find number 3 and with another number 3 because 9 divided by 3 it is 3. And the distance is going to be 0, so this is going to be the final result. Yeah. And for number 10, it's the same. We just need to use a for loop to check number 9 and number 10 together. Yeah. Because this n is equal to 10 to the power of 9, so this means if we use the square root of n, basically it is 10 to the power of 4 to 10 to the power of 5. Basically we can solve it. Yeah. Now let's try to code it up from here. So first of all, we're gonna check the numbers. So for n in range, it's gonna be num plus 1 with num plus 3 because we have two numbers, num plus 1 and num plus 2. And next, we're gonna check all the divisors. So for checking all the divisors, we're gonna use I. So for I in range 1, 2, integer of square root of n plus 1. Then we can check two divisors. So we're going to have two divisors with a and b. So ab should equal to I, going to be the smallest value, and the bigger value going to be n divided by I. Yeah, but before that we need to have a check. So if this number n modular I equal to 0, it means we find a divisor. We find a divisor. Now we need to find another divisor. So it's going to be ab equal to I and n divided by I. Yeah. Now we need to check. So if b minus a less than and equal to result 1 minus result 0. So let's just set a result. So the result, let's set it to be minus infinity, b as infinity. So basically it means from the beginning, this infinity minus the minus infinity is going to be an infinity value because we are going to choose the closest, and b should always be bigger than a. So if it is like that, so we can set the b and a. Yeah, we can set the result. So the result is going to be equal to a and b. And finally, we can return this result. Yeah. Now let's just try to run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all testing cases. As you can see, it passed all testing cases, and it's pretty fast. And the time complexity is the square root of n, and n is 10 to the power of 9. Thank you for watching. See you next time.